Hello everyone. Welcome to our first video for material on the Unit 3 exam. Specifically, this video is going to be on parts of Chapter 8, which is about using a balanced chemical equation to do calculations that we talked about in Chapter 7. So a lot of the skills that you learned in Chapter 6 and Chapter 7 with calculations with moles, you're going to use that concept, but using balanced chemical equations. Okay, so that's what this first little video will be about. So the main point, the main point of Chapter 8 is that when you have a balanced chemical equation, and when I say balanced, I mean number of type of atom on the reactant side equals number and type of atom on the product side. When you have a balanced chemical equation, those coefficients, those numbers out front of each molecule, each reactant, and each product, those coefficients relate reactant and product quantities in terms of moles. So with this balanced chemical equation that's on the screen now, I have CH4 reacting with oxygen gas to give carbon dioxide gaseous and water, gaseous water. From this balanced chemical equation, I can say for every 1 mole of CH4, and it's 1 because, let me get my pointer here, it's 1 because there's an implied 1 coefficient in front of that CH4. For every 1 mole of CH4, I react 2 moles of oxygen, and I produce 1 mole of carbon dioxide and 2 moles of water. Okay? So I use those coefficients to relate moles of one species to moles of another. Doing that has a fancy term associated with it that's called stoichiometry. Okay, so you will hear this term frequently in the chapter videos that I do and in your readings. Okay, so the rest of this little video is going to be using coefficients of a balanced chemical equation to do certain calculations. We're going to talk through some examples, ones that are here on the screen, and also I'm going to do some ones that are on your Chapter 8 practice problem worksheets that I have put on Canvas. But let's start with this one. Let's say I have this balanced chemical equation with hydrogen gas and nitrogen gas reacting to give me an H3 gas. And if I was to say, let's say I was to have 3 moles of nitrogen and excess H2. Now, why saying this will become important later in the chapter. But for now, let's just focus on the 3 moles of N2. If we have 3 moles of N2, I want to know how much NH3 can we make? Well, the only way that I can relate an amount of reactant to an amount of product is through those coefficients of the balanced chemical equation in terms of moles. So I can see from my balanced chemical equation that I have, think about that as being a 1 right there. I have, for every 1 mole of N2 gas, I have 2 moles of NH3. So what I just said verbally, you can see from the coefficients of the balanced equation, and what I just said verbally is written here in terms of a fraction or like a conversion factor. And if I can write something as a proportion or as a conversion factor, then I can do conversion factor problems, or in this case, stoichiometry with them to calculate how much reactant or product I have. So I know I have 3 moles of N2, So I write that down as my given. I am looking for moles of NH3. So when I start this problem, I kind of give myself some space to work it, and I write down the units that I am looking for. Specifically, I am looking for moles of NH3. Then I write my conversion factor such so that my units cancel properly. That means I want the mole of N2 to be in the denominator so I could cancel with my mole of N2 with what's given. And again, these coefficients come from the balanced chemical equation. So written like this, my mole of N2 units cancel. I'm left with moles of NH3 in the numerator, which is great because that's what I'm looking for. So to solve this problem, I just do 3 times 2. That gives me 6 moles of NH3. Okay. So your conversion factor skills, setting up dimensional analysis problems is really going to be helpful in this chapter. Okay. Let's do another example. I pulled this from your Chapter 8 Canvas Worksheet practice problems. So I believe it is number 2B on the practice problems. So let's go ahead and do this using the strategy we talked about in the previous problem. So I have a balanced chemical equation here, and I want to know how many moles of CH4, react with that many moles of NH3. So just like any other conversion factor, dimensional unit problem, write down what you're given. In this case, you're given 10 moles of NH3. Give yourself some space to work the problem. Write down the unit and the species that you're looking for. In this case, I am looking for moles of CH4. And in the space in between, give yourself room to write the necessary conversion factor to solve the problem. So I need to go from moles of NH3 to moles of CH4. I look at my balanced chemical equation, and I see for every 2 moles of NH3, I have 2 moles of CH4. So what I just said verbally, I need to write that down here as a conversion factor. My 2 moles of NH3, that's going to go in the denominator because I need my mole of NH3 units to cancel. So for every 2 moles of NH3, and then in the numerator, I will write down 2 moles of CH4. So just note that I wrote down the number and the unit associated with it. So now my mole of NH3 units cancel. I'm left with the unit that I am looking for, which is moles of CH4. So in your calculator, everything that's in the numerator is multiplied, everything in the denominator is divided. So 10 multiplied by 2. Divide by 2, and that should give you 10.0 moles of CH4. Now on these problems, I'm not going to be picky with sig figs, especially since they're all going to be multiple choice when they are on the Unit 3 exam. Okay? But I would really encourage you when you're setting these problems up, be clear with the units, what's in the numerator and what's in the denominator. That will help you when solving these problems. Okay. So number 1 and number 2 on the Chapter 8 worksheet use this concept of going from moles of one thing to moles of another using the coefficients of the balanced chemical equation. But as you guys know, at least with the labs that we had before, when you work with chemicals in the lab, you don't really work with respect You don't really work with moles when you're weighing things out. You weigh things out in grams, right? You care about the mass of a reactant or the mass of a product. Well, that's fine. We know how to go from a mass of one thing, specifically grams, to moles of that same species. You guys can do that using the molar mass of that substance. That's where your handy dandy periodic table comes into play. You use the atomic mass of each element in a molecule, add them all up, and that's how many grams that element weighs or that compound weighs in 1 mole. Okay? So we can use this concept of molar mass along with ratios from the balanced chemical equation to do stoichiometry, to do unit conversion problems with regards to not just moles, but with a mass of a molecule, specifically a mass in grams. So I've got this example here. We're going to talk through it also on the other slide, and then we're going to talk through and do an example that is on your Chapter 8 Canvas practice problem worksheet. So let's say I was to give you this balanced chemical equation that is also a redox reaction, but I've got C8H18 liquid reacting with oxygen gas to give me carbon dioxide gas and gaseous water. And I want to know what mass of carbon dioxide, so I'm looking for grams of CO2, is emitted by or produced by a car that uses that amount of octane. Octane is C8H18. So I have grams of a reactant, and I need to get grams of a product. And so the way to do this is to use both the concept of molar mass and of the coefficients of the balanced chemical equation in our calculation. So I'm going to talk through this example. Then we're going to, I know it says work in class, so then we're going to do this one in the video, and then that'll be the end of this little vignette. So I've got this balanced chemical equation. I want to know how many grams of CO2 is produced from this many grams of C8H18. So there's no direct path to go from C8 to H18, or to go from C8H18 to CO2. I can't do that in one step. I have to go through our favorite unit, the mole. And as we said, the only way we can relate moles of one thing to moles of another is by those coefficients of the balanced chemical equation. So looking at that balanced chemical equation, I see I have 2 moles of C8H18 to every 16 moles of carbon dioxide. That's great, and we are going to use that, but before I can use my mole-mole ratio, I have to first get my C8H18 into our unit, favorite unit, the mole, which is what is done here with this first step. I go from grams of C8H18 to moles of C8H18 through the molar mass of that molecule. So this 114.3 was 8 carbons plus 18 hydrogens. Each carbon is 12.01, each hydrogen 1.01. Add that up, you should get 114.3. There's that many grams in 1 mole of that molecule. Doing that, my gram units cancel. I'm left with the moles of C8H18 in the numerator. Now I'm at the point I can use those coefficients of the balanced chemical equation to relate moles of one thing to moles of another. So those coefficients I'll write as a conversion unit so that my mole of C8H18 cancels with my mole of C8H18 from the molar mass. So after my second step, I'm left with moles of carbon dioxide. I'm almost home. Remember, my target is grams of CO2. Right now, I'm left with moles of CO2 The way to get from moles of CO2 to grams of CO2 is from the molar mass again, but this time of carbon dioxide. So 1 carbon plus 2 times the mass of oxygen should get you 14.01. And again, that molar mass is written, so my mole of CO2 units cancel. I am left with grams of CO2 in the numerator, which is what I'm looking for. And so now we can stop our unit analysis problem and put it in our calculator. So again, everything that's in the numerator multiplied, everything that's in the denominator divided. And you should get 1.5 times 10 to the 3 with 2 sig figs. So I would encourage you to get your calculator out, make sure that you get this answer before moving on to the next problem that we're going to do to end this little video, which is to use this concept of molar mass and coefficients of the balanced chemical equation to solve this practice problem. Okay. So let's say I was to ask you how many grams of chlorine gas are needed to make 117 grams of sodium chloride. I ask that question, and then I give you this chemical equation. But before you even start your unit analysis problem or writing down what you're given and what you're looking for, you should always look to make sure that the chemical equation is balanced, meaning number of type of atom on the left is equal to number and type of atom on the right. Because if it's not balanced, then the coefficients are going to be wrong and your mole-mole conversion units will be incorrect. So, is this equation balanced? Nope. I have 2 chlorines on my reactant side and only 1 on the product side, so I have to put a 2 in front. So my chlorines are now balanced, but sodium's not balanced. But that's okay. I can put a 2 in front of there. So now we have a balanced chemical equation that we can use on the next slide, which is the last slide for this video, to solve this problem. How many grams of chlorine gas are needed to make 117 grams of sodium chloride? So I now have my balanced equation. I write down what I'm given, 117 grams of NaCl. I write down, give myself some space to work the problem. I write down the unit that I'm looking for. So I'm given grams of one reactant. I got to get to grams of product. The only way I can do that is through moles, but I got to get my grams of NaCl to moles of NaCl first, and I will use the molar mass of sodium chloride to do that, written so that my gram units cancel. Now I'm at the point where I can use the coefficients of the balanced equation to relate moles of one species to moles of another. And I see for every 2 moles of NaCl, there is 1 mole of Cl2. Again, remember, if there's no coefficient out front, that means 1. So I write that accordingly so that my mole units cancel. My mole of NaCl cancel. I'm left with moles of Cl2. I'm almost there. I got to get to grams of Cl2. So I'm going to use molar mass to the rescue again. Again, written so my mole units cancel of chlorine. So in your calculator, again, everything multiplied in the numerator, divided in the denominator. So out of your calculator should pop up the answer 70.972. If we were to round to 3 sig figs, and I say 3 because our answer or the reactant information was given for 3 sig figs. If we were to round that to 3 sig figs, it would be 71.0. Hopefully you can tell that's a 7. Okay. But again, I'm not going to be picky with sig figs. What I want you to be able to do is to be able to feel comfortable setting up these kinds of stoichiometry problems. So this example should be helpful to you when doing number 3 on your Chapter 8 worksheet. In the next video, we'll do a review, and then we're going to go on to a concept called limiting reactants.